Hey, welcome back to the Routing Loop, everybody. My name is James Wenzel. Everybody calls me Jamie. You've seen me before. I've been hosting the show quite a bit, and I've brought back a good friend and a colleague that I work with all the time. It's been a while since I think you and I have done this together. Satish, why don't you introduce yourself? Tell everybody what you do and all the cool, fun stuff that you're involved with, and then we'll get into the meat of the show.
Great. Thanks, Jamie. Good morning, good afternoon, good evening, everyone. I'm the product manager for VPC Lattice and look after the application networking services broadly as well. Looking forward to discussing all the new stuff that we're building and things that you can do today. So looking forward to the chat.
Cool. So project manager or product manager, tell me a little bit about, I mean, we've had product managers on the show and talked a little bit about what they do and what the core function is, but it's been a while. I think it's almost been like a solid year since we've actually discussed it. So it's worth bringing it back up. Like so you say the product manager of Venus or of Lattice. What does that mean? Like what does Lattice do? And what does a product manager do to make Lattice do whatever it does?
Right. Yeah, I'm starting with writing the PRFAQ, as you know, in the Amazon style, creating the concept like Lattice concepts, etc. Other product managers before me have done that, and then the day-to-day operations are more about saying, okay, what else should we build next, and then
what else should we build next?
Yeah,
you hear that, folks? This is the person to ask.
And at the same time, also, things that we've already built, making sure that they're running at scale, right, for all of our customers. Obviously, things pop up every now and then, dealing with either LSEs or outages, etc. And obviously, talking to customers, understanding what our roadmaps are, where things are going, what's coming next, short term, long term. And also looking broadly across AWS and going, not just focused on the one service or two services that the product manager usually owns, but looking at the broader AWS landscape and going, how do these all come together to make it easier for our customers to deploy their business critical applications or other use cases that they want to build, etc. And then the third part of the product manager's role is about just making sure that we are in tandem with engineering, managing the day-to-day stuff, but also looking further out, like a year out, 2 years out, and saying, where should we be? What are the things we can work on internally, operational improvements, and externally for what might delight our customers?
Yeah, exactly. Hello, Ken. Ken says hi to you, Satish. Apparently, you guys know each other. Yeah, so let's just double click a little bit on the roadmap and what's coming up. We're going to talk about today of what has been recently released, of course, but talk to us a little bit about how you decide what features and what capabilities that you add. Of course, most of the people here who have an SA or have an account team, which any AWS customer does, has probably heard of the term PFR. Tell us a little bit about how that works and what that sausage factory looks like.
Yeah, sure. So PFR stands for product feature request, right? And as the name says, it's about things that don't exist in that particular service yet that you want to see, right? So in Lattice, it could be something like cross-region. That's a very popular ask. Lattice doesn't support cross-region like other AWS services today because it's very regional. So things like those that come up, and then we talk to customers and go figure out what are the different use cases? What does cross-region mean? Like to define it very clearly, right? So that it comes from, hey, this broad concept of we need to talk to applications across regions down to, hey, we need it for DR capabilities, active backup, failover. Do you also need it for other AWS services, or is it just for your services? So then we whittle it down and say, okay, what is the bare minimum that we need to build? What is the MVP, right? Minimum viable product. So for that particular feature. And then that's sort of what PFR devolves into, and then it sort of internally becomes a roadmap item and phases and which phase has what features. And then when we roll it out, we coordinate with Jamie, who's a prolific blog writer, and other essays who would write tons of blogs, right? And sort of show how that feature actually comes to action in terms of all the different Terraform, CloudFormation, CDKs, etc. How do you provision it? And then we give you examples of through the blogs on how to deploy, right? Examples of how to do that. So that's sort of what is a life cycle of a PFR, starting with the definition, then building it, and then releasing it, and then obviously maintaining it for almost forever.
Forever, yeah. I don't know how many times I've heard about people asking me about CLB going away. I'm like, it's deprecated. We're not working on it, but it's still there. It's like, it's one of those things that once it's relied upon, you can't really pull the rug out. But yeah, no, it makes sense.
Customers rely on these services, right? Customers have built their existing business workflows, processes, etc. So deprecation is not something is taken lightly. It's super, super critical. At the same time, the many reasons for deprecation, because there's something better, or we built some other service that is doing more for customers, and then we obviously work with customers in migrating them easily and with enough time. Like App Mesh is a good example. App Mesh going away by September, so therefore, urging customers to find alternatives, which we have built with Lattice in one way, with ALBs, so different possibilities exist.
Yeah, no, that makes sense. So I guess to come full circle, now that we've talked about what it takes to build something, or what you use as a qualifier for PFRs, as well as also customer feedback. PFRs isn't the only way, right? We've got multiple different signals. SAs bring things back. Customers talk to us directly, all of that. Why don't we start looking at what you've released recently? Because you've been pretty busy lately, haven't you?
Yes, yeah. It's been a busy, keeping engineering busy as well, very clearly. So we've done a lot of different features around Lattice, and Lattice being a router, load balancer, security enforcement, zero trust, observability. It's got a lot of different tentacles, if you will. So they have to address different things in different ways. So if I can share a couple of slides, I can sort of go through.
Go ahead.
More recently. Let me start with this slide, right? So first thing, region expansion. This is one of the critical things for product managers, again, to figure out, okay, what my service should be available in all AWS regions, right? So today, of the 38 regions that we already have, we're in 29 already. The most recent one was in Mexico Central. We launched that at the end of April. And then second is the Oracle databases. And customers have already known this. We've launched this about a year ago now. But we keep adding new regions to this as well, so that customers can directly connect their Oracle databases in AWS to their applications, with Lattice being the underlying construct. And then the two...
Can we just double click on that one just a little bit? I've had some customers ask me, like, I get that, I want to do it, but how does that work?
How does the Oracle database work? Okay. So let's say that in a given region, let's say US East 1, right? Oracle databases are co-located within AWS availability zones. So managed by Oracle, they're not part of AWS. And then there's a connectivity between them through DX directly into AWS, the VPCs. That is managed internally by AWS. So you don't see it as you don't have to go set up your own DX, Direct Connect, and that's already set up. So now, once that DX is there into an AWS and Oracle managed VPC, which is managed by, again, AWS, what the customers would see is a connection from that VPC to their VPCs. And that is where Lattice comes in, and you can connect your VPCs. The two use cases for it, right? So S3. So if you want to back up your Oracle database to S3 or do any ETL backups, that's already the database that you operate and manage can go directly to the S3 in that region through Lattice. Those are the typical use cases. So imagine
we got a question from Tech. Exadata, does it run in OCI in this case?
That's right. Yeah, it is managed by OCI. It's think of it as an OCI cloud extension, right? And that is running co-located in an AWS data center.
Another question we got from Ken. What about the interconnect? Can we use that for connectivity?
Yeah. So from Oracle database into your VPC, that's all standard DX in that region. But from your VPC, you can always use interconnect to go to a different region, right? So that's a great use case, Ken. Yeah.
Cool. Yeah. Sorry to interrupt you. Keep going.
Yeah, no, that's the second big piece, like, in Oracle databases, and we're seeing a lot of those use cases with fully managed ETLs and S3 backups, right? The third one in this list is about custom DNS for Lattice resources, right? So this is what we had done at the end of last year to give you a very good sense of this feature. In Lattice services, which are layer 7, you could already add a custom domain name. When you create the service and give it a custom domain name, and then the client side, it resolves to the Lattice 169.254 if you do a VPC association or a service network endpoint. Right. Same thing for Lattice resources, which are TCP resources, and now you can assign them custom domain names. You can assign verified domains, especially with the ISV use cases. You can say, I don't need to validate the domain. So it already comes validated. I add the custom domain name, and I control the private hosted zone creation on the consumer side. So you can tell us, hey, for this domain, go and create the private hosted zones across all of the consumer VPCs that have a service network endpoint or a resource endpoint. So this is huge in terms of automating the custom domain name creation and also the private hosted zone management on the consumer side. Right. So,
well, think of it like this too, right? If you can just go ahead and flip a switch and say, hey, everywhere I have an association or an endpoint, create a DNS name, you don't have to go and hunt down for where all those are.
That's right.
Right. Which could be like if you have a very large system, and a lot of our viewers do have some fairly sizable environments, that could be a nightmare.
That could be, yeah. Route 53 profiles was built to solve that to some extent, right? And say, hey, here's the alias record or a CNAME record for that particular domain, and then you go and associate that profile across a bunch of VPCs. Mm-hmm. With Lattice, what happens is each of the endpoints has a unique DNS name, so you'll have to still manage a bunch of Route 53 profiles, which doesn't quite solve the problem. So that's why we built the automated way to say, you tell us, and we go create the private hosted zone. Today, it's owned and managed by Lattice, but there have been asks from customers around, hey, let us manage them as well. Right? Don't just you just create them and let us manage them.
So stay tuned, maybe some things in the future, right?
Right. Yeah,
as we know, we can't talk about, we can't
Yeah.
talk about roadmap items, but we can talk about what we have noticed. But one thing too, I just want to also comment, I've always done this in the past, and I know others do it, especially in the app networking world. When you're looking at using DNS and Route 53 or even Bind or Microsoft DNS and all that stuff, it's a great place to variabilize connections, right? So if you need to swap something in and out real quick, DNS is a great place to say, hey, instead of this address, go here. I mean, we've been doing that for a long time. Having it set up now where you can do a custom name, easily identify the core pieces of your Lattice service network and your Lattice services, and you want to do swapping in and out, even at the DNS level, even though Lattice gives you tons of ways of doing it at the at the network level. It's just another tool in your toolkit, I think.
Exactly. Yeah, this is helpful in migrations, right? Let's say customers who have peering or TGW today and are running into IP exhaustion problems, right? And then say, look, I want to migrate one or two accounts to Lattice to alleviate that pressure on IP exhaustion. That's DNS is a great way to sort of migrate that. Like what used to be on the TGW, you resolve to IP address of an ALB or NLB running on the destination side, right? Mm-hmm. And just flip that private hosted zone entry, the CNAME record or the alias record, to the Lattice generated DNS name. So now that path is going over Lattice. So both paths can exist in parallel too. That makes migration a lot easier and easy to flip back if you run into any issues, and then you can choose to migrate one VPC at a time, one account at a time, one service at a time. So at your flexibility.
Yeah, exactly. No, you're absolutely correct. That is very powerful.
And so on that same note, what we did with the low IP usage was when you create a resource gateway, right, on the provider side, that's where you create the Lattice resource configurations like DNS, ARN for RDS, and IP as well. So before, resource gateways were always allocating /28s, which required contiguous IPv4s being available in your subnets. Mm-hmm. And that was a problem because other services in AWS go and fragment the subnet space. They allocate IPs randomly for good security reasons and all that. So we removed that restriction on resource gateways now. So you can assign just a minimum of 2 IPs per subnet. and you can assign up to 62 IPs per ENI without contiguity. So we remove the contiguity requirements. It'll go and allocate the IPs one at a time without requiring contiguity. So that frees up a lot of different use cases and stuff, so that you don't have to worry about fragmented subnets and CIDRs.
That's pretty good, because I do remember too, like if you want to use Resource Gateway in a SaaS-like model, right? Remember, it's different than private link. Private link, unidirectional stateful flow, one IP address, multiple targets behind a NLB, whereas Resource Gateway is more of a one-to-one, going through a resource config that could either be singular or have many children. And we've discussed before about using FQDNs or ARNs or IPs as your pieces. But now this solves a bunch of issues where if you were, say, a provider and you have to ask all your customers, hey, make sure you have a contiguous block in all of your VPCs that want to use our service. Now that that's no longer a thing, this definitely could free this up as a pretty good contender for some of the edge cases or for different types of workloads that you need in a private link resource linky fashion, not just with Lattice, but also with Resource Gateway on its own.
Right. Yeah, and Resource Gateway is Lattice, so let's not even.
Yeah, I know. I get what you're saying, but we're identifying the one piece of, like, you don't need to have the service network for the Resource Gateway, but you can still have the Resource Gateway and use those pieces. Is what I meant. I should be more clear. That's why we have the PMs on, folks. They correct me.
Yeah, we are particular about those, just because it's like why do we make sure that customers shouldn't be shouldn't have to care first. It's like, hey, give me this connectivity. Underneath it's whatever the name is, and then so this is why we built it this way. And then it's also the same thing that we built for the next features set is around latency reduction for resources, right? So we've done some improvements. So because customers use these resource gateways and Lattice resources for layer 4 connectivity to some databases, their clustered applications, potentially they can do things like connect to Kafka, to MSK by self-managed mode today. And so there we worked on reducing the latency a lot. So P99 under 1 millisecond. Nice. For, essentially what happens is the connection setup goes through the slow path, but once the connection is set up, the rest of the packets just flow through the fast path, and that's why you get the P99 1 millisecond latency. And then, as you know, there's only a 350-second idle timeout today on resources, and there's no connection limits, right? Like, unlike services, we have a very strict 10-minute connection duration time today, but on resources, so depending on the use case, you're free to use either one.
So would you say that resources are like NLB-like, where as long as you maintain the connection, it stays up?
That's right, yeah.
Which is also pretty good too, because I actually have talked to some customers that literally have had NLBs where they have a connection that's been alive for almost a year, if not more, right? Yeah. So I guess they could do the same thing with Resource Gateway. This is not a feature that we found. This is actually something built into Resource Gateway. And we intend it to be this way. So if you are using it for long-lived connections, have no fear. We're not going to pull the rug out from under you later on. You haven't discovered an undiscovered bug or anything. This is intentional.
Yeah, as long as you keep the keep alives to avoid the 350-second idle timeout, then there's nothing enforced in our data plane. We're not terminating the TCP and reissuing the TCP like we do on layer 7, where we terminate HTTP if you want us to, versus like the TLS pass-through mode. So yeah, just like that NLB, long-lived connections, customers use it for WebSockets sometimes if they need to just run it plain TCP.
ERP transactions that have to go through, that take forever. Yeah. So no, it's definitely one note I want to say on this too, though. That's pretty important to note is when you're looking at these long-lived connections for either NLB or Resource Gateway, I do get asked questions a lot like, how come we don't have a feature in NLB or in the Resource Gateway to do the keep alive itself? And quite simply, it's a feature that would cost a lot of processing power for us to do it on our end. And it could be costly if you're doing something like private link across to another customer and you're constantly sending them traffic or keep alive traffic or anything like that. So what we usually ask our customers to do is to build that piece in the app. We will honor it, But our load balancers and our resource gateways are not meant to drive it. It's meant to follow your lead. So build it in your app, have your keep alives in your clients or whatever you want to do. We will honor that, but we do not put that into our products because we don't want to have any wasteful spend or wasteful spin or churn on anything processing that could be used by another customer or yourself or undue charges. So we just figured it was the most easiest and cost-effective measure to have the customer, do that as opposed to us. I just had to throw that in there because I can't tell you how many times I've had that, like, how come NOB just doesn't do this? And it's like, there is a lot of reasons. It would be very cool if it did, but I don't think they would like it, in the long run, if the cost of that were passed.
Essentially, it's a multi-tenant environment, noisy neighbor. If connections are marginally expensive, right? So holding up resources. I mean, just like imagine, when you run your servers, right? You don't keep connections around forever,
right?
Unless absolutely needed, right? So that's the same reason. Imagine us being a proxy for your servers, and that's exactly what we are doing too.
Exactly. No, exactly. What else we got?
What else we got? So private DNS, right? This is another key feature that we just launched that was around. So as resource configurations go, like DNS resource configs, right, in Lattice, those were required to be only publicly resolvable. They were resolved to your private IPs in your VPC or on-prem, but they were required to be publicly resolvable. And what customers had asked for, and we already had this long ago in our roadmap, was to make it just resolvable in the VPC where the resource gateway is. Privately resolve it, go to the private hosted zone in the destination VPC, and then resolve it, right? So this is where you can have a DNS config now and set a flag on the resource gateway and have it be privately resolvable. So now, instead of our Lattice data plane looking at the resource config DNS name, trying to resolve it publicly, it'll send the DNS resolution through the resource gateway to the .2 in the destination VPC. Or if you have an outbound resolver endpoint that goes out to your on-prem and resolves it there, both are supported. So the private DNS is a good use case, and I'll share more in the next few slides when we get to the agent core integrations as well. So this is a key feature.
Yeah, no, that's a good one. How many people were asking? Just curious, how many people were asking for the private DNS? Because I think I got someone asking for that like almost the first day that Lattice launched.
Yeah. Yes. Yeah. Yeah. So the challenge with that is because the reason for initially launching with public DNS was it supports pretty much most use cases, especially when customers wanted to get to ARN, right? ARN, RDS databases, and AWS services are publicly resolvable. They resolve to private IPs, but they are publicly resolvable. If you have ALB or NLB as a DNS name as well. So those were already supported. So that we addressed in the initial launch. But then, especially finance customers and highly regulated industry customers have asked for, look, we don't want any public resolution of our domain names at all. So we want it to be privately resolvable and within our VPCs and sometimes on-prem. And so that's where this came from.
Okay. So we've got two security related ones coming off the back of that. I'm just going to bring it up. First, I'm going to bring up Ken's comment, PFR for WAF. You and I both heard this one quite a bit.
Yes, yeah. Ken, yeah, that's a good one. I know this comes up a lot, but so I want to understand the use case further, right? Like typically WAF is for north-south ingress for DDoS protection and then any like a website traffic. So most customers typically do the WAF on the ingress through either API gateway or through ALB. And then the east-west traffic over Lattice is with the authentication authorization, you're reasonably secure, right? As in that is a zero trust authentication mechanism. So once WAF has done its job on the north-south, it's there. But is the ask here to say, hey, WAF on the east-west as well to be able to go from one service to the other?
Yeah. Ken, why don't you let us know, just pipe that in. But I will also bring up TechFuel because I did promise to bring this up and you've segued it in perfectly. Any insights as to when VPC Lattice will support east-west inspection, ditto for MTLS? I'm going to take a real quick stab at this. One of the things that I've done, and then of course, Satish, you keep me honest. one of the things that's very, very powerful if you're using Lattice service-to-service communications is you have, essentially, if you have 2 services and 1 service network, you have 3 security checkpoints, right? You have the security checkpoint of the service network, which is an IAM policy, hopefully. And you can put your macro policy in there. And then you also have it on each of the services. Now, I've had some FinServ customers who ask very, very much the same question. They come back to me and say, hey, Jamie, we love Lattice. We love what we can do with it. There's all these cool things that we're doing. It's fairly dynamic, but we have a hard requirement for east-west inspection. What do? We need to prove to our auditors that we have firewalls between our services. And to my reply, silly customer, Lattice is a firewall, right? If you look at the way that the IAM is set up and the way the policies are set up, you could literally export, and I've seen financial services do this and healthcare services do this. They will export those policies and hand them over to the auditor and say, this is our firewall. And then as long as they can prove that it does stop, they've accepted it. I haven't heard of anyone who said, I'm not going to accept this as a firewall or as any type of security policy, because literally it's baked into the product. So I've done a lot of yapping there, Satish. Why don't you color in your commentary there?
Yeah, that's exactly right. So customers typically replace their east-west firewalls, especially if they're at layer 4, right, with Lattice policies. Essentially, cost savings plus a centralized way of enforcing them through Lattice auth policies. So in the layer 4 level auth policies, you could just say source IP, source VPC, same exact things you were enforcing with firewall. Yeah, resource, exactly. And so you can do that today, right? Especially for services. We don't have support for auth policies for resources yet. So you can do that today. So that's why east-west inspection, if you're doing just layer 4 firewalls in between to control access, that's already possible today in Lattice. The second piece is around doing more of a IDS, IPS, like a payload inspection, right?
Right.
That's where we don't support that today, and obviously I can't talk about roadmap stuff, but that's been a constant ask. On the second item about MTLS, we don't terminate MTLS and do the client-side certificate validation today, but if you put Lattice in the TLS pass-through mode, you can do MTLS yourself, right?
Right.
If the goal of MTLS was to say, look, I want certificate-based authentication and authorization between 2 services, and you most likely won't use Lattice auth policies then, right? And you could put Lattice in TLS mode, TLS pass-through mode, and then we don't break the TLS, we pass it on. You could still do network level controls. We don't have visibility into layer 7, but you could still do things like source VPC, source IP, source account based controls, even with MTLS. So that gives you
headers,
additional capability.
Yeah, exactly. And the other thing too, don't forget that Lattice is also very good at saying, if you're not wrapped in TLS, you can't talk at all, right? So that's yet another layer saying, if it's supposed to be MTLS wrapped traffic and you're not seeing any MTLS, it gets stopped right at the service network, if that's part of one of your policies.
Right. So hopefully for Tech Fueled, hopefully that answers both of your questions.
Yeah. And then to follow up for Ken, he says, imagine if you have B2B partners accessing Lattice services and you want to protect your published Lattice services.
Right. Yeah, this is like a very standard use case, like third-party partners accessing your Lattice services through a service network. Let's say you create the service network shared with the third party, and they associate their services with it. The first thing you would do is put a service network level policy that says only allow these accounts. So these B2B accounts are the only ones, even if you share it with a whole bunch of others, for example, the policy says, okay, only allow from this B2B partner or from that B2B partner's account, right? Step 1. Step 2, you could add a policy at the service level that says, same thing, only allow access from this particular account from this B2B, and also even a particular service. If the B2B supports adding Lattice SIG-before signature, then you have the principal earned from the calling service, and you can have a policy that says, hey, on my Lattice service that I'm connecting with the B2B third parties, only allow access from these specific B2B third parties as well. So you have 2 degrees of control already. And even before you do these 2 degrees of control at the service network and service level, just by the RAM sharing of that service network, only sharing it with the B2B partners, that limits the exposure to start with. and then you layer on the service network level policy to make sure that even if it was shared inadvertently with other B2Bs, they may see the service network, they may associate their service with the service network, but you won't allow the traffic through the service network level policy. And then the third one.
I was going to comment on that. I've even seen some of our partners doing things like when the customer has a client, there's a token within the client that must be seen before it could actually connect over the service network. So I've seen other things too, where customers are getting, our customers, which are partners and to our customers, that where they build in a mechanism of authentication, specifically taking advantage of the IAM policies on the service network, saying if you don't have this, you're not allowed to talk. And then what they do is they'll just, when they sign on a new customer, they'll add a new token into the service network and say, okay, this token is now authorized to speak. If you don't have these sets of tokens, you're not talking over this particular service network, period.
I see. Tokens enforced through like a specific header value in the
Yeah. Exactly. Yeah. It's like you could do, there's so many different ways of being able to pull this off, that it is kind of daunting in a way when you're looking at it, where you would normally have just, I'm going to put a Palo here or ANF, or I'm going to do this and turn on this and this, and then there it's done. With Lattice, you have many more levers and dials to pull and push just because of the fact of what you can do with IAM and SIG4 and all that other fun stuff. One more follow-up from Kenatar before we move forward. He asks, what about rate limiting for services? I've seen an interesting way that this has been done, believe it or not, taking advantage of the ability to split your traffic, bifurcate your traffic. But I'm curious to see what you have to say, Satish, and then I'll give the pretty cool method that somebody else built.
Oh, cool. Yeah. So there's a default rate limiting available today, right? Like the 10K requests per second that we already have as a per AZ limit for each service. If a client exceeds that, we send a 429 back today, right? So that's throttling is available by default. What we don't have is a way to flexibly control that and say, hey, for this service, only allow 5K requests per second per AZ, for example, right? And some customers have asked us for, hey, 10K requests per second is not enough. My service needs 100K requests per second per AZ. So we have accommodated those as well. So that's why that quote is on our documentation. It says flexible, reach out to your TAM or the account manager to reach out to us for increasing the limits, and we evaluate them. But yeah, in terms of rate limiting for services, there's a default one available. The configurability is not there yet.
Yeah. What I've seen in for some of the more interesting architectures, I've seen some customers actually do two paths to a service, where one path is the fast path, one path is the slow path, where it's intentionally slowed down, where in one regard, not to get too much into the weeds of what they've done, one was like a direct access to a service, and the other way to slow it down was direct access to a queue that has access to a service. So whenever their backend is getting absolutely annihilated, they actually will switch the traffic over to take the queue route. And the queue route will slow things down, but things don't get dropped. Right. And then once things start to pick back up, or things are, their backend is better, or their migration, what they've done is salient, they can switch everybody back over to the fast path. And the cool bit is the way they did that. The customer never knows, right? The customer never sees, just because, again, they're playing DNS tricks, a resource gateway endpoint trick, and then from behind it, they basically have the two identical services in two different ways, and they just give it two different paths. It's actually very, once you see it, it's like one of those things you can't unsee it. It's a pretty interesting way of doing it, but you have to be pretty dedicated for this. They were also injecting things within the queue, for when things were slowed down, and sending notifications, because this was a break glass event. It wasn't like every single day they're switching back and forth between these two things. But again, with the abilities of being able to send your traffic to multiple services using the same service, cross IP not being an issue, it does unlock some pretty cool ways, pretty cool designs that you can do for shaping and sending your traffic.
Yeah, that's awesome. I'm glad to hear the SQS or some other queue mechanism to sort of save this in the same traffic, playing the DNS games on the client side, right? Being able to switch between the two with using resilience controller, ARC, or other
Exactly. Oh, Arc is definitely involved. Yeah, this is a very popular customer. Everybody knows him. That's why I don't want to say anything. But you can when their traffic is on, like when an event happens, they need to make sure they don't go down. Right. So that's what they did. That's what we talked about, and they were able to slow things down without losing, and then let things speed back up when they weren't getting hammered so badly.
Yeah, sounds that's great. Good to hear.
Yeah, it's cool. So. All right, what's up next? Unless you have any comments on rate limiting for services beyond what you've already discussed.
No, that's where we are today with our rate limiting. So expect a default 429 right now with 10K or your increased throughput limits if we increase them for you. I do want to talk about the Gateway API controller for EKS, right, or your native Kubernetes workloads. Yeah. So we've done a lot of work there as well. So the more recent version, 2.1.1 that we just launched, has a whole bunch of features. This is a way for us to provide a very native Kubernetes API experience, right? So instead of doing anything, if you're a pure EKS shop, right, single cluster, multi-cluster, multiple VPCs, multiple accounts, have a very Kubernetes native way of provisioning and getting Lattice services in place and connectivity, et cetera. So customers like this a lot because they don't have to go outside of Kubernetes to do anything else. This is all built into the Gateway API controller with the new Gateway API spec. Right? So the more recent things, yeah.
Go ahead. Please finish.
More recent things we did was to sort of have the certificate manager, injector integration with Webhook TLS. So you can now just say, hey, here's my cert manager. And then the immediate next thing to that was what we built in is a way to say, hey, here's my service name, HTTP route, host name. Go look in ACM and figure out what the certificate is, and do that periodically to update it and use that certificate through the Kubernetes API when you provision the HTTPS service. Right? So this simplifies customers from having to go and say, hey, add the ACM certificate ARN in the deployment manifest, and then rotate them as they need to. They'll have to build webhooks to go and rotate them and see whenever ACM rotates them, right? So this was natively built now into Lattice controller, similar to what ALB does as well. So this is what you were used to, and we did that. And the second thing was to make the external DNS CRD. This is how you specify custom domains with the Kubernetes API for Lattice services. So it's like very easy to install through Helm or through your deployment manifests directly without Helm as well. And the last thing more recently was the drift detection, right? So if somebody goes and says, hey, I set up my IAM auth policy through the controller, but then somebody went and changed it to the CLI or through the console, the controller would do the drift detection, and then we extended it to, obviously, service networks and services were already there. So if you go and change something on the service, the drift detection kicks in and makes sure that it's consistent with your deployment manifest. So those are the immediate things, but the Gateway API controller itself, like multi-cluster use cases, are super popular with customers deploying in a very Kubernetes native way.
I mean, I want to point out, that this is something that should not be slept on, especially with Lattice. Like usually for the load balancer controller, which is very, very similar platform as you mentioned for ALB and NLB, and using those as Ingress controllers, and that it can't be. I can't overstate, or what is this? It can't be overstated that the controller also helps with the whole point of Lattice, right? The idea that Lattice will allow you to set up an application service network, and the service owners own their service network policy. All they have to do is connect up to Lattice, right? They set their own policies as to who can contact them under what conditions, and then others do the same, and your security grows organically. The whole point with Lattice is you're not supposed to be, or you don't have to be a network genius to run your service on Lattice, right? You just have to run your service and connect up. This does one step further, where it says, okay, you don't even have to worry about Lattice commands for your service, right? You just have to use your native Kubernetes API and configuration, and this built-in capability now will launch those Lattice services for you. Once again, making it even easier. So if you know Kubernetes, right, it's a couple of extra things you got to learn to have your network setup via Lattice. All you have to do is just enter in the configuration and away you go. And I don't know about you, Satish, but back in the day before I was a AWSer, I can't tell you how many times I couldn't stand having to do key rotations, right? So now we have these things like ACM, which of course I loved when I became a customer and all that stuff. And now that it's extended all the way down, right, through the controller to somebody who doesn't necessarily have to be a whiz at AWS, they just have to be a whiz at their own service and how to secure it down. Man, that's a lot of unblocking there, I guess is what I'm getting at.
Exactly. Like, the analogy I always use is you just want to drive the car, right? You don't want to understand how the pistons work and what the trigger ratio is and what the fuel injection ratio should be. That's exactly what this ACM certificate rotation goes down to, and automating that and making it easier for customers, but at the same time verifiable, right? And trust but verify, and that's what we try to build in.
Cool. All right, what else have we got? Unfortunately, we only have 9 minutes left, so we have to.
So let me just jump straight to the next one, which is about Agent Core, right? This is probably top of mind for most customers today. So the things that I want to highlight here is what we've built with Agent Core integrations. So Agent Core, the different services underneath that I show in the first column, Agent Core Gateway, which is an MCP proxy, MCP gateway. Identity is a way for you to assign.
Well, let me pause for 1 second. Why don't we just tell the audience, for those who don't know, what is Agent Core?
Yeah, good. Thank you for reminding, Jamie. So Agent Core at a high level is a way for customers to create agents and connect them to their MCP servers and then to LLMs, etc. So Agent Core is a bunch of services that allow you to do different things. Like Gateway allows you to do MCP proxying to anything, to any HTTP targets. We just launched it last week to have connectivity to your own agents as well for A2A. And then identity is a way to assign an identity provider like OIDC, OAuth, etc. Through the Agent Core for your agents and on the behalf of, so it's not just the agent, but it's also agent acting for that time on behalf of the user, right? So that's the multi-level identity, 2LO and 3LO. Runtime is where we provide almost like a Lambda function, right? We provide the underlying compute and the OS and everything else. And you can build agents using our strands or build your own using LangGraph and LangChain, other forgetting the name, other architectures or other frameworks. And then DevOps agent is a broadly useful service in terms of being able to go and understand what's going on with your clusters, going on with ECS or EKS, any other compute type. And then a whole bunch of other things that are being built, AWS security agent, AWS network agent, etc., that give you that ability to have agents now go and talk to the different services and come back and give you that visibility and viability without you having to know the API level details and do it through CLI or have a different way of debugging stuff, right? So this is broadly the Agent Core stuff. And Lattice, we've integrated with Agent Core in different ways. So for gateway and identity, especially with what I mentioned before with private DNS and private connectivity. So Agent Core, gateway, and identity running in the Agent Core in your account, but in the Agent Core managed VPC, connecting to your VPCs through the backend and private connectivity through. So there are a bunch of different modes, which I'll go into in a second. Runtime is interesting because these are agents running at layer 7, right? A2A protocol is HTTP protocol with JSON RPC and built underneath into it for prompt routing, etc. That AI gateways do very well. Customers also do different things with AI gateways going to either Bedrock or other LLMs. So runtime is a way to simply say, hey, look, I'm going to run my agent and you manage the compute underneath. Almost very similar to Fargate Lambda functions, if you will. Right? Specifically, I wanted to cover what we built with Agent Core Gateway. So there are two modes with Agent Core Gateway. So it gives you a way to privately invoke your tools. Right? With Agent Core Gateway, you can also publicly invoke any Lambda function, HTTP, etc. But again, customers want not any traffic not going over AWS network or the internet to invoke tools, but privately from the agent core gateway in their account to their other VPCs and other accounts. Right? That's what we built with Lattice. So there's two modes, managed and self-managed mode. Managed mode is for a single account where agent core gateway itself goes and creates the resource gateways, creates the service network, manages it underneath, and then it allows you to say, okay, here's my MCP target, agent core, and this is a private target. So go through the lattice between agent core gateway and your VPC and access the MCP tools. Right? And the self-managed mode is extending it beyond one account to multiple accounts. You can just go and say, hey, it's not just one account. I'm going to create my resource gateways and my resource configurations for my MCP servers across different accounts. And you share that, RAM share that with the agent core gateway account. And then the connectivity is already established. You don't need any other connectivity between agent core gateway and your VPCs and accounts. So it's the same service network that you're used to, which is managed by agent core. And then it adds your resource configurations from multiple different accounts. And you create the resource gateways and manage them. Now, the reason for the two modes, managed and self-managed, is managed was very simply to say, I just want it for my one account. And I also don't want to go and have to have a separate security approval for VPC Lattice as a separate service. Right? So this is all managed by agent core underneath, and the resource gateway is dedicated only for agent core gateway. And nobody else, no other AWS service can use it and has access to it. So it's a very simple way to say, look, I don't want to spend the time going and getting a separate security approval for Lattice. I just need it for one account. Start with the managed mode, right? And then as you get comfortable with it with the managed mode, then you can extend it with self-managed mode, and then you add Lattice to your SCP policies, et cetera, and allow users to create the Lattice constructs like resource gateways, resource configs, and share them. So those are the quick ones I wanted to mention for Agent Core Gateway. And I'm sure there'll be plenty of questions.
I got one question for you, actually. Just like one of those, what does Satish, the PM of VPC Lattice, think is best practice? If you're going to use VPC Lattice with Agent Core, right, and you have multiple use cases for Lattice, service communication, as well as using it for agentic networking, let's say. Yeah. Do you recommend using the same Lattice network for both, or would you dedicate one versus the other?
You could. My recommendation is dedicate one versus the other, right? So if it's especially with gateway, imagine like the gateway is being able to access your private MCPs in a single account or the other. That is already managed through the Agent Core Gateway managed service network, right? That's already built in for you. Things like when you want to run agents running in your own VPCs and accounts and they need to talk to each other, that should be a separate service network. That is completely different path. They could still be these agents could still be calling the Agent Core Gateway in different accounts through the private link endpoint or through the public endpoints. That is still viable to do it that way. But keeping the agent to agent, all the other traffic separate, and especially if your agents are going to LLMs that you might be running yourself, through AI gateways you might be running yourself, that keeps it really, really clean and separate architecture, separate path, if you will. So that would be the way to start. And then it doesn't preclude you from calling Agent Core Gateways. It just gives you, hey, this is my managed path. I can control all the policies in here. I want a more fully managed option, go with the Agent Core managed option.
Okay, makes sense. Yeah, I always like to make sure that we can get some prescriptive guidance from the PMs that help us build these, actual services. Yeah. So that's a question that I know will come up once I start talking to customers more. So I'm using this forum to get my answers early. How's that?
Exactly. Yeah, and the goal here is to give you enough flexibility, right? It's like the customers, if want to do different things, could be different use cases, etc. I know we're probably running short of time. I just want to highlight this one issue that has come up.
10 minutes. Don't worry. I was a little premature last time. We've got about 10 minutes. So apologize.
Okay. Yeah. So we can always go back to the other questions and stuff. But the last thing I wanted to cover is we're seeing the HTTP stricter validation that was enforced through Nginx. That was the released 129.4.
Mhm.
That was a stable release on April 14th. So customers who are starting to deploy that now might be running into things like, hey, if you suddenly we're using dots in your header names, those are now being silently enforced and dropped in Nginx. So if you're seeing sudden drops with, hey, why is it not working? It used to work with the previous versions. So you might want to check the specific Nginx version. If you upgraded to anything beyond 1.29.4, that's most likely the case where the dots are not allowed in header field names anymore. So we're running into this with a bunch of customers, so wanted to highlight that so people are aware.
They'll need to use Agent Core to build an agent to go through all of their documents to replace the dots with the dashes.
That's right.
No, it's a good call out, though. That is a very good call out, because when you're troubleshooting some of these things, it can get very difficult sometimes, especially for some of these very nested architectures, to figure out where the problem actually is. So yeah,
it could be like depending on where it's in the path, right? So it's always a good thing to sort of understand, hey, look, this is what's happening in the Nginx path. Unless you go through a hop by hop analysis, right? You won't be, but if you know this already ahead of time, and the good thing to do here would be to just replace the dots with dashes or hyphens.
Yeah, hopefully your application doesn't require dots or anything like that else in the back end. So definitely make sure that you check for that. But yeah, this is a great call out.
Good. We can go back to talking about Agent Core more.
Yeah. Yeah, no worries. So one of the things too that it's interesting to me that I'm hearing from customers, especially about Lattice, is that because again of the service network and its ability to inspect or for you to put policies on it, it actually makes it a pretty good place to run agents over, as it is right now. Hence the whole purpose of doing the Lattice and Agent Core Gateway, or not the whole purpose, but one of the main reasons or drivers to do that. What have you seen out there from folks who use Lattice and are now getting heavily into agents? Is there anything that you've seen or any gotchas or something that the audience should know about?
So I think there are few gotchas that will come up, I'm sure, in the future as because of scale or whatever. But what I'm seeing is very good adoption in terms of being able to say, look, I'm going to have these dev accounts deploy Agent Core gateways. Start with, right? They might be using Agent Core runtime to run their agents or their own compute. But they standardize on, let's say, the Agent Core gateway and say, look, every account should have an Agent Core gateway because it's going to do the MCP proxying. And my backends today are my applications. They could be behind an API gateway, ALBs. They could be running on my EKS clusters in Lambdas. I don't have to go and create MCP servers on each one of them. Right? I can just have them be fronted by Agent Core gateway. So one advantage of this is to completely have a Agent Core gateway as your MCP proxy for all your backends. And then now you have private connectivity, go to either one account or multiple accounts and have those be fronted through Agent Core gateway. So you don't have to go and deploy MCP servers everywhere and manage them, right? So you centralize them. You have a good registry with Agent Core registry as well. That's one pattern. And the second pattern is to be able to say, look, I'm going to go deploy my agent on my Agent Core runtime because I don't want to manage compute, or I deploy my agent myself, and I want to be able to say, look, I need an AI gateway in between to talk to LLMs and manage my token spend. Also manage my what LLM am I going to? Is this the best efficient use of my this particular prompt? Like LLM routing that AI gateways are doing and are building more and more of. So I've seen customers being able to just say, look, I'm going to have my agents built on my EKS. I'm going to build them using my LangGraph or LangChain or different frameworks that I want to use. And then I'm going to connect them over Lattice. Right? One of the targets could be Agent Core Gateway in the service network available. And then also go through Lattice to have layer 7 connectivity to other agents, for example. Or egress out of the egress VPC where you have an ad gateway, a firewall already built in, so you go out of AWS to talk to other agents. The bunch of standards evolving as well, like agent discovery, agent naming service is one. So those are all evolving very fast, and they're also coming up. So in terms of gotchas and patterns today, I think it's safer and easier to just go and say, look, I'm going to have a standardized agent code gateway. That way, all of my authenticated, authorized requests go to my backends as MCP requests. And then I'm going to build agents, and the building of the agents can be flexible. And then you can go and choose different frameworks, different compute types, and then have it centralized through the gateway or gateway, agent core gateway, or your own homegrown, like the plenty of different ones like Light LLM or Envoy AI gateways to run them as AI gateways that are also acting as MCP proxies. They have both the capabilities built in. So those are the patterns. The bigger gotchas will be around, hey, for this agent, how do I enforce a time limit? How do I enforce that when you're acting on behalf of somebody, a user that has an IAM role, how do I make sure that the same permissions get carried over to whatever that agent is doing on behalf of that user for that particular duration of time, right? So what we're used to in the network side is, hey, auth identity just carries over to the backend at all times, right? Mm-hmm. Obviously, credentials are rotated, but the verification and the identity persists until that identity is removed, right? But the credentials are rotated. But with agents, we're seeing something new where you want to also limit the time in which that task has to be done, or that agent, that end user has access to that particular task, etc. So those are some of
combating the whole zombie agent thing.
Right. Yeah, zombie agent too, because of things can spin up, like agent creating other agents, and now you get into a recursive loop of whose identity are we assuming. So this becomes like a multi-layer issue compared to what we see.
And if an agent is stuck, it's basically sitting there. It already has an identity. Can something else communicate with it? These are all like these edge cases that we need to be aware of and hopefully be able to handle. And again, with the Lattice service network policies and service policies, you could basically do your best to restrict, but the need for that timeout is definitely there.
Exactly, yeah. And then the enforcement becomes like at agent speed versus human speed, right? Like applications and clients talking to, because of human-driven stuff. Like if you're making a simple travel booking, right? It's now dependent on how fast you ask things to do. But if you allocate it to an agent and say, go do this, here's how much you're allowed to spend, go make this travel plan happen, then now the load on the network and the applications and the authentication and everything else is now at agent speed and not at human speed. Right?
Correct.
Yeah. So that's a key differentiator that's going to come up with additional requirements on the network as well.
That's like going from an F1 car to a jet.
Yeah.
Yeah, no, it's and as you mentioned too, like agent speed, that's a good point. Even overarching all of our networking constructs, like agents now are going to have the ability to demand more from our networking services or put more traffic on the networking services because they can just do things that much quicker. Yeah, no, that's a good point.
So time boundedness becomes more relevant, a lot more relevancy in terms of how quickly should you do, what are the SLAs that the agents offer. So all kinds of new constructs coming up.
Yeah, that's cool. Well, that's just about all the time that we have now. We've got about a minute left. Satish, I always ask all of my guests on the show, what do you want the audience and the folks listening in, what's the one takeaway you want from them from this session?
Yep. So maybe I'll cheat. There's two takeaways. One is very simply, with all the Lattice features that I just shared, right? Like, let us know, keep giving us the feedback on how things are working, particularly with private DNS and what we're doing, and what we've already accomplished with the Gateway API controller. Those are the key use cases that are simplified. Use the GitHub issues on the controller. It's an open source controller. It's open source software, so you can take a look at the code. Feel free to contribute if you feel like it. Then the second takeaway is we've already built a lot of integrations with Lattice and Agent Core, right, for your agentic application, agentic traffic. So start experimenting with that and then let us know.
All right. Well, thank you, Satish. I will definitely have you on more as things get more and more developed here. And we've obviously you're like a machine just releasing things. So thank you for being on the show. Thank you everyone for watching. Tune in next week and see you all later.